Hi class, let's talk about the diurnal temperature cycle. First of all, what diurnal means is over a 24-hour period. So um, based on the diagram, the slide in the PowerPoint presentation, it is conveniently from midnight to midnight is the 24-hour diurnal period that we're looking at here. So this is the figure, the slide from the PowerPoint that is on chapter 4. And just want to indicate that the red line first is the incoming solar radiation curve. The blue line is the outgoing terrestrial radiation, infrared radiation being emitted by the Earth's surface. The green line here is the resulting temperature between the two. Okay, so let's go through this figure now that we've defined what all these different colored lines are. Okay, and so let's just go throughout the night. Okay, and what we're going to be doing is basically comparing the incoming solar radiation to the outgoing terrestrial radiation and see what happens in terms of determining a temperature trend by comparing the incoming solar radiation to the outgoing terrestrial radiation. Okay, so at midnight, as you would expect, in our example here, there is no incoming solar radiation. There is only outgoing terrestrial radiation. Okay, the outgoing terrestrial radiation is cooling the Earth's surface, and so notice the temperature trend is on the decline, as you would expect. Again, you just use your common knowledge, use your intuition, use your experience. Temperatures normally decrease throughout the night, and this is why. Because there is more outgoing terrestrial radiation than incoming solar radiation. And again, around midnight, 2, 3 o'clock in the morning, there is no incoming solar radiation. So as we continue through the early morning hours, so 12 o'clock, 1 o'clock, 2 o'clock, 3 o'clock, I forget where this is on the figure here, but it's all outgoing terrestrial radiation. So the Earth is cooling itself, and that is reflected in the downward trend of temperature. Okay, so here we are at 3 o'clock in the morning, 4 o'clock in the morning, still only outgoing terrestrial radiation, no incoming solar radiation, so temperature is decreasing, and it's decreasing. Now here at 6 o'clock in the morning, okay, notice that this is where sunrise is in this example. Sunrise is at 6 a.m., and so the sun is just peaking above the horizon, so we do have a little bit of incoming solar radiation, but notice there's more outgoing terrestrial radiation. Okay, again, you're always comparing the two. In this particular case, there's still more outgoing terrestrial radiation than incoming solar radiation, so the temperature is still decreasing. We go a little bit beyond sunrise. Okay, maybe this is 6:30 or so, 6:15, 6:30. Notice that there's still more outgoing terrestrial radiation than incoming solar radiation. Okay, even though the sun's been up for, again, maybe 15 minutes, a half hour or so, there's still more outgoing terrestrial than incoming solar, and as a result, our temperatures are decreasing. Okay? So we get to the point now where the incoming solar radiation now equals the outgoing terrestrial radiation. Okay? At this point, we reach our minimum temperature for the day. Okay? So we reach our minimum temperature for the day, our low temperature for the day, when the incoming solar equals the outgoing terrestrial. Okay? Before that time, temperatures were still decreasing. So you might intuitively think that temperatures start rising as soon as the sun rises, and that's just not the case. The sun, we are receiving incoming solar radiation, but there's still more outgoing terrestrial radiation, so temperatures are still decreasing until a little bit after sunrise. So our low temperature, our minimum temperature for the day, does not occur until shortly after sunrise. Okay. Now we go throughout the morning and now notice that incoming solar radiation is greater than outgoing terrestrial radiation, and as a result temperatures are increasing. Okay. You keep going through the morning. Here we are about 9 o'clock in the morning, more incoming solar radiation than outgoing terrestrial radiation, so the temperatures are increasing. Okay. 10 o'clock, 11 o'clock in the morning, more incoming than outgoing, so the temperature is increasing. Okay. We get to solar noon. Okay. At solar noon, this is when the solar noon sun angle is at its highest in the sky. There's more incoming solar radiation than outgoing terrestrial radiation, so temperature is still increasing. Okay, but this is going to be our maximum amount of incoming solar radiation throughout the course of the day. Okay, so once we get a little bit past solar noon, notice that the incoming solar radiation starts to decrease. But also notice that the incoming solar radiation is still greater than outgoing terrestrial, so our temperature is still increasing. Okay, go a little bit more into the afternoon. Okay, we are losing some incoming solar radiation. We reached our peak at solar noon, and now we're receiving less incoming solar radiation, but it's still greater than outgoing terrestrial radiation. Okay, so the temperature is still increasing until later in the afternoon. Okay, and at this point, now incoming solar radiation and outgoing terrestrial radiation are once again equal. And so this is when you reach your maximum or high temperature for the day in a typical day. Okay, and so our maximum temperature does not occur at solar noon when we are receiving our maximum amount of solar energy. The high temperature for the day actually occurs later in the afternoon. And again, you probably experience this throughout your lifetime that, yeah, the high temperature doesn't occur at noon, it occurs later in the afternoon. And so the high temperature occurs when the incoming solar radiation and outgoing terrestrial radiation are equal to one another. Okay? As we continue on our figure here, later in the afternoon, late afternoon, now notice that outgoing terrestrial radiation is once again larger than incoming solar radiation. Okay, we're getting closer to sunset. The sun is still in the sky, but it's at a lower angle such that the amount of incoming solar radiation is less than the amount of outgoing terrestrial radiation. So as a result, the resulting temperature trend, now temperatures are starting to decrease. We reached our maximum when incoming solar and outgoing terrestrial were the same. Now outgoing terrestrial is greater than incoming solar, and so our temperature starts to decrease. And as you would expect, that temperature is going to decrease throughout the rest of the early evening hours into the next morning. Okay, so sunset around 6 p.m. Outgoing terrestrial is still greater than incoming solar, so temperatures are decreasing. Sunset at 6 p.m. So after 6 p.m. there is no incoming solar radiation, there's only outgoing terrestrial. So our temperature trend continues to decrease, and temperatures will fall throughout the night, okay, until you get, again, back to the next morning and we start that cycle all over again. Okay. Other things that we need to point out about the diurnal temperature cycle is, in this example, when do we receive incoming solar radiation? Again, this is the nice perfect example. Sunrise at 6 a.m., sunset at 6 p.m., so a 12-hour day. When does the Earth emit its energy? When does the Earth re-radiate the energy that it has absorbed? Okay, and that is 24 hours a day. The Earth emits its energy throughout the course of the day. That's another radiation law. Okay, any object above absolute zero is going to emit energy, and so the Earth's surface is above absolute zero, so it is emitting energy 24 hours a day. It doesn't care if it's winter, summer, it doesn't matter. the Earth is always emitting infrared terrestrial outgoing radiation. Okay? But the question is, when does the Earth emit its most energy? Okay? And so you'll notice that the Earth emits its maximum energy typically mid to late afternoon. Okay? Why is that? That's another energy law. That's Stefan Boltzmann's law. The hotter the object, the more energy it emits. So if we take a look at the temperature curve throughout the day, in a typical day, our temperature is going to reach its maximum in the afternoon. So when the Earth's surface reaches its maximum temperature, that's when it's going to be emitting its maximum amount of terrestrial outgoing radiation. Okay? All right, so that's the diurnal temperature cycle. So make sure that you understand this figure for the next quiz that's coming up. Okay? And if you have questions on it, be sure to contact me.